Good day to you people of the internet. Got an exciting video, or potentially series of videos for you today as I look into getting this 1978 Space Invaders Deluxe cabinet up and running. Now we really got our work cut out for us. This cabinet itself is just an empty shell. The artwork on the side and front look pretty good. The control overlay is rather rough, but more importantly the internal artwork is all original and looks great. We're missing a coin door, speaker, pretty much all internal lighting, the fluorescent ballast and starter, and then, you know, on top of that, like I said, the cabinet itself is empty. The guy I got it from gave me all the parts I really need to get this up and going, but they're in an unknown state and, you know, in a pile over here. So we've got the CRT chassis, the CRT itself, a linear power supply, a couple of Space Invader boards, a couple of sound boards. I think actually one of them is for a deluxe and one of them is for an original. So let's turn this cabinet around and take a look at what we got. So chances are we're going to have to service quite a bit of this cabinet throughout the restoration. So the only sane place to start is with the power. So I'm going to go ahead and clean up this power transformer, the holders for the 1 and 3 amp fuses, which are missing. We're going to have to put a new end on or replace our power cord completely because that's pretty roughed up. And then we're going to test the voltages coming out of each of the legs of the transformer and compare it to what we find in the schematic. Went ahead and replaced the missing connector on our stock cable, cleaned up the transformer and checked the solder joints. Now this orange cable leads up to the switch on the cabinet, and that solder joint was pretty bad. Looked like it was about to fall off. So went ahead and redid that. Cleaned up our fuse terminals and replaced our missing fuses. So next step is let's apply power to the cabinet and test the incoming and outgoing voltages on this transformer. But before we do that, there is a paper label here. You can probably make out the label but not read it from the camera view. And this is telling us our expected incoming and outgoing voltages. So on the bottom, far left, we've got our neutral. Far right, we've got our ground. On the top, we've got 16.5, 9, common tap, 16.5, 9, another ground, and then 12 volts. So let's apply some power and see what we get. I don't know if you can pick it up on camera, but we definitely have some voltage hum going, so that's great. So all incoming and outgoing voltages from this transformer are going to be AC. We haven't rectified anything yet. So I'll set our meter to AC. Now I went ahead and clipped my negative lead to the neutral side. And let's test the incoming voltage from the wall. Alright, a good strong 120 volts, 121 volts. Now we'll move over to the common tap because we'll be testing the outputs of this transformer. Let's see what we're at. So this is supposed to be 16.5 and it looks like we're getting 18.9. Now I think that this is okay because as we noticed on the label of the transformer, it's expecting 115 volts. And the way I understand things is that might be the way that wall outlets used to be back in the late 70s or early 80s, but now we're working with 120 or 120 plus volts as you've seen on the meter, so I'm expecting the outputs to be a little bit high. What we don't want to see is zero voltage. Okay, so continuing on, this is supposed to be 9, and we're reading slightly over 10. We've got our common tap. This should be 16.5. I'm sorry. This is 9. We're reading 10. This one's 16.5. We're reading 18.8. We've got another ground here. So let's move over to that. And we'll check this last voltage here. This should be 12, and we're coming in at 13.9. So our transformer looks pretty good. Next step would be the power supply for the unit that this transformer feeds into. Now originally, these midway cabinets had these linear style power supplies. And I got this from a gentleman, as described earlier, and I'm not sure if he did some work on it or if this was from a parts pile that he just had. But we can see some replacement caps here, some little caps up here. Looks like some replaced resistors. It looks like some of these components here may have been replaced. You can see by the mess of flux on the bottom there. But even more worrisome is some spots there's lifted traces, or for example, a trace is completely missing and it's just kind of repaired with the lead of the component. Now, okay, it looks like a lot of work's been done. We could try this out. But then I discovered that there is just some diodes that have broken off. Now, I'm sure this happened while sitting in a box. But in order to replace all these components, hell, why not recap it anyways? You're looking at quite a bit of money. Now, they sell modern switching power supplies for these units. And from what I've read online, these old Midway cabinets really don't suffer any side effects from being converted to a switching power supply. Say like something like a newer cabinet might. So from arcadeshop.com, I was able to pick up a great deal on a little switching power supply here and a Midway adapter board. Now the idea behind this board is that there's these little legs with voltages silk screened onto the board, and that corresponds to points on the switching power supply. So we can see here 5, ground, ground, -5, and 12. So this would kind of plug in under these clamps, then your wiring harness would plug right in. Now, for whatever reason, they are not pulling AC from this plug like they do on the linear power supply. They're having you wire it up yourself. So they provide some kind of little patch-in cables, and yeah, I'm just not feeling it with these little splice connectors and whatnot. So what I'm going to use is just a chunk of computer power cord, and then I'm going to make my own little cable and have it connect to the same feed points that the monitor is going to be connecting to. So that's basically the input neutral and the input hot of the transformer. So I'm going to get that done and mount the power supply probably somewhere right about here, and I'll see you guys again in a few minutes. Turned out nice and clean. With a chunk of that cable, we were able to make a power cord going from ground, neutral, and hot over to a couple of spade connectors here to feed our new switching power supply. The Midway board is installed and connected to our wiring harness. So the next step is to apply power to the cabinet and check the voltages, say, on the L connector that'll connect to the PCB. Now, something to note, on most arcade cabinets, there's this little safety switch up here in the top. Now this is for when the door is closed and the switch is pushed in, it'll allow power to flow. But when you're servicing it, you don't want to hold that button in. You can just pull it out and it'll lock the switch into the on position. So here is the edge connector that's going to supply voltage to our PCB board and where we're going to get our video signal out to the CRT monitor. Now from this schematic I was able to find online, I can see the pins 1, 3, and 5 are propagated on our plug, and they should be 5 volts, 12 volts, and -5 volts. So I will focus down on the meter here, and we'll switch our meter to DC because the switching power supply converts the AC to DC. We'll find a good grounding point on the back end of this capacitor here. And we'll apply power to the cabinet. Looks like our switching power supply came on okay. So let's check at the bottom, pin 1. 5.27 volts. Now a little over is okay. Once the board is connected, it will use some power and that voltage may adjust. Pin 3 should be 12 volts. Okay, pretty close, just a little hot. And the -5 volts is a little bit low. We may need to tweak that adjustment knob on the power supply, but again, things may change when the board's connected. Alright, now that we know that our power is good, the next place to move to would be the CRT and the CRT chassis. So here we have the CRT chassis. Right off the bat we can see that the diode holder on the flyback transformer is broken. The unit is pretty dirty, and heck, all the electrolytic capacitors are like 44 years old at this point. So we could just apply power to it, but I'm thinking that's a bad idea. So I'm going to go ahead and work on getting this board recapped, cleaned up, and then give it a good visual inspection, test some transistors and things like that. But that's going to be a good topic for a whole nother video, so I think we'll kind of stop it here, and then I'll make part 2 in a little bit where we kind of go through recapping this chassis and testing it out. Alright, see you guys then.